Hi everyone, this is Josh Groh and Elliot Knapp here to teach everyone how to do the Geometric Optics Thin Lens Lab for Honors Physics with Miss Hall. So first, a little bit of background information about this lab, and this is important information so you want to listen up. When light passes at an angle from air to a denser substance, such as glass, the light rays will bend. The bending of light is called refraction. Lenses refract or bend light. Convex lenses, which are thicker in the middle than at the edges, cause light to converge at a focal point. Concave lenses, which are thinner in the middle, cause light to diverge or spread out. The images formed by refracted light are either real or virtual images. Real images can be focused on a screen, but virtual images cannot. Also, images can be either upright or inverted. Upright images have the same orientation as the object, but inverted images are upside down. Alright, so for part one of the thin lens lab, we need to gather our materials. So, first, you need a stack of books. These books will hold the lamp, which is right here. You're going to hold the lamp right there, or it'll stay in place like that, and then you'll plug it into an outlet, and the light will shine from there. Then you'll need 3 pieces of blocks of wood. So here, have all 3, and Miss Hall does a great job of putting them out for you, so you'll see them. And then you need 3 holders, and each holder is going to contain a certain object. So this is going to contain the arrow, or we call this the object, and it's on a piece of cardboard, and you're going to stick that in the first wood block. Then you're going to gather your lens. Now your lens is very important to grab the right lens in the first part of the lab. The first lens you will need is going to be in a red container, and you will not know the focal length. That's what you're going to solve for, so you can't know the focal length, of course. So make sure you grab a red piece of lens. And then, luckily there's one already in there, so you're going to put that in the middle block of wood. The last thing in the holder will be a piece of cardboard, which the object will be displayed on when the light is shown through the object and the lens, and you're going to put that in the final block of wood and set it behind the lens.
Alright, so to begin, you need to plug in your light source, and as you can see, we now have the 3 holders lined up. So your object is going to be close to the light again, and you need to choose a location for your lens and then record the distance the object is from the lens, and that'll be your distance for the object. We'll move the last holder correspondingly. And so around here is good for this lens. Now using the meter stick, you can record between the 2 holders. So that's about 27 centimeters for this one. And your next step is to find the location where the last holder has a focused image of the object. So around there is good. And now you want to take a distance from the lens to the last holder. That's about 33.5 centimeters. And then you repeat this step 3 or 4 times more. So moving it farther, closer away, and then adjusting the last holder correspondingly. As you can see, it's in focus there again. And record your data in the table. Using your data that you've collected in centimeters, you're now able to find the focal length of the lens using the thin lens equation.
Alright, so we're back with part 2 of the lab. Now this part is entitled Predicting Image Distances. So for this part of the lab, we'll use a lens with a known focal length and predict the image distance using 2 different methods. Then you will check the actual image distance and calculate the percent error. Choose an object distance larger than 1.5 focal lengths away. Record all of this information in your lab notebook. So first, we're going to predict the image distance using the object distance method. So First, we have to measure the object distance. So this object distance is from the object to the lens. So you're going to take your meter stick and measure from the object to the lens, so how far that is. And then, because you're using this time a lens with a known focal length, which you have here is 25 centimeters, since you know that, you can use the thin lens equation to solve for the distance of the image, which is from the lens to where the image is being projected. Okay, so for part 2 of part 2, we're going to use a different method to figure out the image distance. So this time we're going to predict the image distance using the ray tracing method. So,
Alright, so now we can find the actual image distance and compare it to the two previously predicted image distances. So we have here an object distance of 55 centimeters, and as you can see, the image is now in focus on the other side. And so the image distance that we found looks to be around 22 centimeters. And so using your values that you got for the ray tracing method and the thin lens equation, you can find the percent error of your calculations.